place in the universe you talk about, as you know, scares some people. Someone once told Sagan that they didn't like astronomy because it made them feel small and insignificant in comparison with the grandeur of the universe. It clearly didn't affect you that way.
Well, it depends on what your ego is going into the conversation. If your ego starts out, I am important, I am big, I am special, you're in for some disappointments when you look around at what we've discovered about the universe. No, you're not big. No, you're not. You're small in time and in space, and you have this frail vessel called the human body that's limited on Earth. If you have no ego, if you just want to explore the world, look what happens. Here's the conversation goes differently. You learn, oh, the molecules and the atoms of those molecules in my body are traceable to stars across the galaxy that have lived their lives, manufactured these elements, exploded them into the universe, from which new generations of star systems were formed. So I look up at the night sky, I don't feel small, I feel large. I feel connected to the universe. It's not just we here on Earth, and that's there. We are one. And that link, for me, is one of the most profound discoveries of modern astrophysics. And if that should not make you feel small, that should make you feel large.
What is the practical difference it makes whether or not we find out what dark matter and dark energy are?
If you were around in 1920, maybe you would have been saying, what's the practical difference of measuring the behavior of atomic nuclei or atoms themselves? We can't see atoms. Why do I care? This is just wood. This is a wood table. I'm in a leather chair. I'm good to go. Why are you investing so much energy, so much brain energy on understanding what's in the middle of an atom? That seems like a waste of this brilliance. In the 1920s, in addition to discovering we're not the only galaxy in the universe and that the universe is expanding, that's a watershed decade, because in that decade, quantum physics was discovered. And perhaps if you were around asking me that similar question then, you'd have questioned the whole enterprise. Yet today, a third of the GDP of the world is generated on the creation, storage, and retrieval of information. And the entire IT revolution cannot exist without an understanding of what's going on inside the atom. It is a quantum physics phenomenon. So you ask me I have no idea what value it is. Come back in 50 years, we'll have this conversation, and you pull up the tape, and I will show you asking me of what value is the knowledge of how that works.
I was going to ask you, because if the universe, that term, if that phrase, if the universe is pulling itself apart, does it ultimately disintegrate? Does it ultimately collapse?
No, there's no evidence to say that we will ever recycle ourselves. All evidence points to we're on a one-way trip to oblivion. So the universe expands, the temperature of the universe drops, all stars eventually will run out of fuel, so the stars, one by one, in the night sky will turn off. And in the extremely distant future, a quadrillion years into the future, there'll be no light coming to us in the day or night sky. And because all stars would have died, and all gas clouds would have made stars that were going to make them, and there'd be no more new stars created. And so that the universe will end not with a bang, but with a whimper, and not in fire, but in ice.
You think there could be another universe?
I don't see why not. Because back when we thought Earth was alone in the universe, we learned that there are other planets, that the Earth is just a planet, one of many. Well, the sun is surely special. No, the sun is one of 100 billion other suns. The galaxy, the Milky Way. No, the galaxy is one of 100 billion galaxies. How about the universe? We have philosophical precedent to suggest that why should nature make anything in ones? Okay? Everything else we ever thought was unique or special, and we found more of them. So philosophically, it's not unsettling to imagine more than one universe. We also have good theoretical grounds for suggesting the existence of a multiverse, where our universe is just one of some countless number of other universes coming in and out of existence. with slightly different laws of physics within them. So that makes it a little dangerous because we are held together, evolved in a universe where we work where we work physically. If you want to visit another universe, I would send something else ahead of you. And so yes, you go to our space show. It is the real science, and it is captivating you the way we'd only perhaps had thought science fiction could.
Well, science fiction came first in a way, in terms of popular entertainment.
In some cases, but I'm a fan of J.B.S. Haldane once said, I'm paraphrasing, he said, the universe is not only stranger than we have imagined, it's perhaps stranger than we can imagine. And when you realize that, you understand why some people don't need to read the science fiction. Because black holes flaying stars in orbit around them, and planets that have life forms undreamt of on Earth, we're speaking real stuff here. Maybe that's as seductive as the imagination of someone standing on the frontier.
So when a child sings, or used to sing, I don't think they do anymore, "Twinkle, twinkle, little star, how I wonder what you are," it's not twinkling. Something powerful, dramatic, and dynamic is happening to it, right?
Well, yes, and we call that twinkling.
Yeah,
so,
right.
Yeah, there's starlight coming billions of, or millions of light years, well, it depends if it's a galaxy, hundreds of thousands of light years across space, and it's a perfect point of light. As it hits our atmosphere, turbulence in the atmosphere jiggle the image, and it renders the star a twinkling. And by the way, planets are brighter than stars typically, like Jupiter and Venus. Venus has been in the evening skies lately. And if you go "Twinkle, twinkle, little star, how I wonder what you are," and you want to wish upon the star, most people are wishing on planets. Right. That's why the wishes don't come true. Because the planets are the first stars to come out at night.
Don't you sometimes feel sad about breaking all these myths apart?
No, because I think it's some myths deserve to be broken apart out of respect for the human intellect. That no, when you're writhing on the ground and froth is coming out of your mouth, you're having an epileptic seizure. You have not been invaded by the devil. We got this one figured out, okay?
An incredible flash of energy and light, though.
And matter, and yeah, all of this, all of the above.
Do you give people who make this case that was the beginning and that there had to be something that provoked the beginning, do you give them an A at least for trying to reconcile faith and reason?
I don't think they're reconcilable.
What do you mean?
Well, so let me say that differently. All efforts that have been invested by brilliant people of the past have failed at that exercise. They just fail. And so the track record is so poor that going forward, I have essentially zero confidence, near zero confidence that there will be fruitful things to emerge from the effort to reconcile them. So, for example, if you knew nothing about science and you read, say, the Bible, the Old Testament, which in Genesis is an account of nature. That's what that is. And I said to you, give me your description of the natural world based only on this. You would say the world was created in 6 days and that stars are just little points of light, much lesser than the sun. And in fact, they can fall out of the sky, right? Because that's what happens during the Revelation. One of the signs that the second coming is that the stars will fall out of the sky and land on Earth. To even write that means you don't know what those things are. You have no concept of what the actual universe is. So everybody who tried to make proclamations about the physical universe based on Bible passages got the wrong answer. So what happened was, when science discovers things and you want to stay religious, or you want to continue to believe that the Bible is unerring, what you would do is, you would say, well, let me go back to the Bible and reinterpret it. Then you'd say things like, oh, they didn't really mean that literally, they meant that figuratively. So this whole sort of reinterpretation of how figurative the poetic passages of the Bible are came after science showed that this is not how things unfolded. And so the educated religious people are perfectly fine with that. It's the fundamentalists who want to say that the Bible is the literal truth of God, and want to see the Bible as a science textbook, who are knocking on the science doors of the schools, trying to put that content in the science. Enlightened religious people are not behaving that way. They're saying, yes, science is cool, we're good with that, and use the Bible to get your spiritual enlightenment and your emotional fulfillment.
But do you have any sympathy for people who seem to only feel safe in the vastness of the universe you describe in your show if they can infer a personal God who makes it more hospitable to them, who cares for them?
In this, what we tell ourselves is a free country, which means you should have freedom of thought. I don't care what you think. I just don't. Go think whatever you want. Go ahead. Think that there's one God, two gods, 10 gods, or no gods. That is what it means to live in a free country. The problem arises is if you have a religious philosophy that is not based in objective realities that you then want to put in the science classroom. Then I'm going to stand there and say, no, I'm not going to allow you in the science classroom. I'm not telling you what to think. I'm just telling you in the science class, you're not doing science. This is not science. Keep it out. That's when I stand up. Otherwise, go ahead. I'm not telling you how to think.
I think you must realize that some people are going to go to your show at the planetarium and they're going to say, aha, those scientists have discovered God, because God, dark matter, is what holds this universe together.
So is that a question?
It's a statement. You know they're going to say that.
So the history of discovery, particularly cosmic discovery, but discovery in general, scientific discovery, is one where at any given moment there's a frontier. And there tends to be an urge for people, especially religious people, to assert that across that boundary into the unknown lies the handiwork of God. This shows up a lot. Newton even said it. He had his laws of gravity and motion, and he was explaining the moon and the planet. He was there. He doesn't mention God for any of that. And then he gets to the limits of what his equations can calculate. So can't quite figure this out. Maybe God steps in and makes it right every now and then. That's where he invoked God. And Ptolemy, he bet on the wrong horse, but he was a brilliant guy. He formulated the geocentric universe with Earth in the middle. This is where we got epicycles and the machinations of the heavens. There was still a mystery to him. He looked up and uttered the following words: when I trace at my pleasure the windings to and fro of the heavenly bodies. These are the planets going through retrograde and back. The mysteries of the earth. When I trace at my pleasure the windings to and fro of the heavenly bodies, I no longer touch earth with my feet. I stand in the presence of Zeus himself and take my fill of ambrosia. What he did was he didn't invoke Zeus to account for the rock that he's standing on or the air he's breathing. It was this point of mystery, and in gets invoked God. This, over time, has been described by philosophers as the God of the gaps. Mm-hmm. If that's where you're going to put your God in this world, then God is an ever-receding pocket of scientific ignorance. If that's how you're going to invoke God, if God is the mystery of the universe, these mysteries, we're tackling these mysteries one by one. If you're going to stay religious at the end of the conversation, God has to be more to you than just where science has yet to tread. So to the person who says, maybe dark matter is God, if the only reason why you're saying it's because it's a mystery, then get ready to have that undone.
How do you explain that no present-day scientist, present company accepted, is a household name, the way Thomas Edison or Einstein were? What does that suggest to you?
If I had to pick, I'd rather they were scientifically literate and didn't know the name of any scientist, because that matters much more. It matters much more that you understand what it means to pull oil out of the ground, or the energy content of oil versus wind versus sun versus, that matters. It matters that you know that an asteroid has our name on it and how it might strike us and how we might deflect it. That matters. It matters what is happening to your health. This requires a base level of science literacy that I don't think we've achieved yet. You have not fully expressed your power as a voter until you have a scientific literacy in topics that matter for future political issues.
And that scientific literacy spares you tomfoolery from charlatans, right?
Yes, exactly. A science literacy is an inoculation against charlatans who would exploit your ignorance of scientific law to take your money from you or your opportunity from you.
Speaking of scientific literacy, I brought along some disturbing statistics. As you know, American students are performing poorly on international tests for math and science. In science, we came in just ahead of Russia and on a similar level as Italy, Latvia, and Portugal. In math, fewer than 9% of our students scored advanced, compared to a whopping 55% in Shanghai, 40% in Singapore, and more than 16% in Canada.
Yeah, welcome to the new world. Yeah. I mean, okay, there's that fact that you just read. Now look at the rising economies in the world, the rising and falling economies. It's going to track those numbers. The beginning of the end of what we thought of as America. As I grew up in an America that had as a priority leading the world in every metric you can assemble for yourself. So this is the writing on the wall. Now, why hasn't it happened sooner? Because a lot of these numbers have been around for decades. Yeah. I have a hypothesis. I didn't do the experiment, but it's not good enough to only be smart at something or to score high on an exam. At some point, you have to step away from the exam and say, I have a new thought that no one has had before. And it's not a thought that you told me to regurgitate on this exam that you just wrote, because it's a thought that no one has had before. And how do you get those thoughts? You get those in irreverent cultures. Possibly that has delayed our collapse because it is out of the environment of not regurgitating what someone else has learned in their lifetime that allows you to make a discovery that no one else has made before.
You think there are too many tests? We give kids too many tests?
I think we put too much emphasis on what the meaning of the test is. I test people. It's a way to find out what you know. But don't then say, if you don't know this, therefore the rest of your life is screwed. No, because go find people who are successful in this world. Find, talk show hosts and comedians and novelists and attorneys, and go get the politicians. Put them in a room and say, how many here got straight A's throughout school? None of them are going to raise their hands. By the way, throw in inventors. Throw in all these people. None of them are going to raise their hand. Okay? So Bill Gates dropped out of college. Michael Dell dropped out of college. Those people are not, the success of those people is not measured by how they performed on the exam that you wrote as professor. Because they're thinking in ways that you have yet to think, because they're inventing tomorrow. And the only way you can invent tomorrow is if you break out of the enclosure that the school system has provided for you by the exams written by people who are trained in another generation. Being at the top of your game, intellectually, philosophically, politically, is not a forever thing. I read history. I look at countries that rise up and contribute mightily to eradicating ignorance and to making discoveries about our place in the universe. And then by change of force, by change of vision, by short-sighted leadership, the entire operation collapses. Look at Islam 1,000 years ago. Baghdad was the center of the intellectual, it was the intellectual capital of the world. While Europe, they were disemboweling heretics. Okay? That's why our numerals are called Arabic numerals, because they pioneered the use of these numerals and invented algebra, itself an Arabic word, an algorithm. 2/3 of the stars in the night sky have Arabic names. How does that happen? Because they had navigating devices, astrolabes. that culture of discovery ended and has not arisen since. I look at America, post-war 20th century America, and say we were at the top of our game, investing in science and engineering and education. And yeah, we had our inequalities and we had our problems. But as culturally as a nation, we had our vision statement. We were thinking about our future. We weren't thinking about the now. We were thinking about the tomorrow. That's what the World's Fair was. Inventing a tomorrow that doesn't yet exist today. When that's how you think about your country and run your country, you have policy that points in that direction. Innovative, inventive, creative policy that takes you from the present into the future. Without it, you live in the present and the rest of the world passes you by. You might as well physically be moving backwards, because that's what you look like to the rest of the world. So as a scientist, I don't care who does the work next. If it's not America, I want to see good scientific results no matter where they're done. But as an American, I feel it. I feel the fading of our luster, the fading of our vision statement as a nation.
I saw a quote recently by the physicist Jonathan Hubner, who says humans are running out of world-changing inventions. He says, quote, "I think the major branches of discovery are behind us." Do you agree?
Of course not. Oh my gosh. That is, I would say this to the man's face. You can't be more, let me be polite. Previous statements such as that made by physicists of the past have proven to be extremely short-sighted. How's that for polite?
That'll do.
Okay, so there's a physicist, one of these Nobel Prize-winning physicists in the 1800s going into the 1900s, the turn of that century. We were at the top of classical physics. Newton's laws were working, electricity was understood. We had the power of knowledge of the laws of nature. And they said, but there are a couple of things. There's still some unknowns, but that's just a matter of getting an extra decimal place in the measurement. But we're done. We're done here. Just a few clouds on the horizon. We're good to go. Don't become a physicist. There's nothing left to discover. Right. And what would happen in the next 20 years? Relativity would be discovered, special relativity and general relativity, the expanding universe, quantum physics. All of classical physics would be turned on its ear because of the discoveries in the very 2 or 3 decades to follow the uttering of that statement. So, of course he can't see the future. That's kind of what it means to not be in the future. Half of my library are old books because I like seeing how people thought about their world at their time so that I don't get big-headed about something we just discovered, and I can be humble about where we might go next. Because you can see who got stuff right and most of the people who got stuff wrong. So let's go through. Let me first start off with Ptolemy. I don't know if we know that he really looked like this, but Ptolemy, was one of the greatest scientists ever and most influential scientists. And his most important work is, of course, Almagest, which is Arabic for the greatest. And in it, he sort of codifies the geocentric universe. And this Earth-centered universe prevailed for centuries until Copernicus and Galileo turned that around. But what I want to call your attention to are notes that he penned in the margin of the manuscript of his work. Let me remind you that back then, you would look up at the night sky and the planets would move against the background stars. They would wander, because that's what the word means in Greek, is wanderer. And there were 7 of these objects, the sun and moon included. And they would just kind of move, they'd go to the left, and then they'd slow down and pause, and then they'd back up, and then they'd reverse again. And this was a mystery, complete mystery. And of course, the heavens were not Earth, And so the fact that you didn't really understand what was going up there was kind of okay and expected, because that was the work of the gods. And we, being mortal down here on Earth, if you can't understand it, don't lose sleep over that fact. You perhaps never will. Now, Ptolemy had sort of the best going explanation anyone had put forth with the epicycles and the like. But nonetheless, this is the boundary between what is known and unknown about how the machinery of the universe works, and he pens these words, which for me are one of the most beautiful and poetic references to the state of one's knowledge ever written. I know that I am mortal by nature and ephemeral, but when I trace at my pleasure the windings to and fro of the heavenly bodies, I no longer touch earth with my feet. I stand in the presence of Zeus himself and take my fill of ambrosia. And so therein is this emotional, he's got this sort of religious feeling at the limits of his knowledge. And this is a trend that will continue for thousands of years to follow this. At least 2,000 years to follow this. And you don't have, and this whole notion of intelligent design, this is intelligent design. This quote that I just read to you is Ptolemy invoking intelligent design. No, he's not trying to get that into the classroom. He's not, there's the politics of intelligent design in modern times. But what I think has been swept under the rug that we have to contend with as a community of people who are sort of truth seekers is the fact that some of the greatest minds that have preceded us have done just this. Okay? That's Ptolemy. But we can go on. Who else do we have? Oh, Galileo, interesting case. Galileo was kind of an exception to this. We all know he was a deeply religious man, and a lot of the trouble he got into was because he was just kind of obnoxious, all right? He could have made nice with the Pope, and he did not. And of course, I'm paraphrasing. I mean, that's the Reader's Digest version of what happened over that period. But let me share with you some lines that he wrote to Christina, who was the Grand Duchess of Tuscany. Some of these quotes you've heard before, but I think they're worth taking to heart. The Bible tells you how to go to heaven and not how the heavens go. That's one of the famous quotes attributed to Galileo. Another one is, I don't feel obliged to believe that the same God who has endowed us with senses, reason, and intellect has intended us to forego their use. And so he was kind of I see him as one of the first to say, all right, if religion has if there's any point and purpose to it, it's not to serve as a science textbook. Okay, so he was kind of the first to suggest this division, not to get rid of religion. Of course, like I said, he was a religious fellow himself. But it gets interesting when we get sort of philosophically interesting when we get to this gentleman. I can back up here. Sir Isaac Newton. Now, I don't know what you know of Isaac Newton, but everything I've read of his tells me that there's no greater genius to ever walk the surface of this earth. I'm just I don't know if you've ever felt that about anybody. I didn't feel that about anybody. But you just read what this man wrote, okay? Line by line by line. This guy was plugged into the machinery of the universe. I think he's unimpeachably brilliant. Unimpeachably brilliant. And let me read again what we heard from Mike Shermer earlier in Isaac Newton's writings. By the way, in his Principia, here's the page 1, page 0 of Principia. In it, he discovers the laws of motion, F equals ma, discover the laws of gravity. It's all there. And he did this all before he turned 26. And in this, when he talks about motion, there's no reference to God. When he talks about his two-body force that he deduced, this universal law of gravitation, there is no mention of God. It's just not anywhere there because he understood it. He was on top of it. He was there. Even though the understanding of the motions of the planets before he came along was given unto God because nobody understood it, or nobody understood well enough to really believe that they had a full predictive handle on it in the way the universal law of gravitation supplied. And so what you have is Isaac Newton abandoning reference to God until he realizes that if all you do is calculate the two-body problem, here we have like the moon and earth. Yes, he's got that calculated. Now you have the sun and the earth. You got that. But wait a minute, now the Earth and the Moon go around the Sun, and sometimes we're close to Mars and sometimes we're not. And when it comes near Mars, there's a tug that's stronger there than in any other part in the orbit. And then it comes over here, and then Jupiter tugs. And it's all these mini tugs. And so he's got to do this two-body problem for Earth, the Moon, Earth and the Sun, Earth, Moon, and Mars, Earth, Moon, Mars, and Jupiter, and it becomes a rapidly complex problem. And he realizes that, in fact, applying this simple sort of approach to calculating the stability of the solar system, he finds he can't stabilize the solar system. He can't account for how we have stayed this way for as long as what was possibly necessary from the beginning of the universe. And so what does he say? He's at his limits. He's at his limits. And so you read but God is nowhere until you get to the general Sholem. And then he says the 6 primary planets. Back then there were 6 planets, okay? Now there's 8, in case you haven't been keeping track. Even if you thought there were 9, there are now 8. The 6 primary planets are revolved about the Sun in circles concentric with the Sun, and with motions directed towards the same parts and almost in the same plane. He's got the whole picture now, and he's trying to sort of account for that. But he can't just simply doing two-body calculations, certainly not without a computer or without a new kind of mathematics. He says, but it is not to be conceived. But is it not to be conceived that mere mechanical causes could give birth to so many regular motions? This most beautiful system of the sun, planets, and comets could only proceed from the counsel and dominion of an intelligent and powerful being. This is Isaac Newton invoking intelligent design at the limits of his knowledge. And I want to put on the table the fact that you have school systems wanting to put intelligent design into the classroom, but you also have the most brilliant people who ever walked this earth doing the same thing. And so it's a deeper challenge than simply educating the public. It's deeper than, as you know, by the books written by our scientific colleagues that do take these deeply resonant and charitable positions towards their religious beliefs. Maybe the real question here, let me back up for a moment. You know, we've all seen the data. 40%, there's 90 whatever percent of the West or the American public believes in a personal God that responds to their prayers. And then you ask, well, what is that percentage for scientists? Averaged over disciplines, it's about 40%. And then you say, how about the elite scientists, members of the National Academy of Sciences? An article on those data recently in Nature, it said 85% of the National Academy reject a personal God. And then they compare it to 90% of the public. You know, that's not the story there. They missed the story. What that article should have said is, how come this number isn't 0? That's the story. But let's move on, because there's more to talk about here. We don't have to stop at Newton. Let's go to Christian Huygens. All right? Brilliant scientist. I mean, he was great at chemistry, biology, physics, math, Dutch scientist. And he died the year that this work was published, one of my favorite works of science writing, and it's Cosmotheros, which is an exploration on the likelihood of there being life on the known planets, using the available knowledge of the day. So, for example, they knew that, by the way, Huygens was the first to identify Saturn's ring as a ring. If I got that right, Carolyn, is that correct? Oh, no, I thought he was the first to calculate that it would be a ring. He was then Huygens would be the first to observe it. Okay. We have Madam Saturn here in the room, in case you don't know. Okay. My colleague Carolyn Porco, who we'll be hearing from later, I've just been told. But anyhow, so Huygens, brilliant fellow, and one of the probes on the Cassini spacecraft was called Huygens, a European probe that descended to the surface of Titan. And so he's an important figure in the history of science. So what does he say in his writings? Well, you look at the year 1696, gravity was well known, laws of motion were well known, Newton was quite influential well before the turn of the century there. And so when he talks about the orbits of the planets, it's done. Talks about the moons of Jupiter, done. Talks about the new rings around Saturn, done. It's all fine. But when he talks about biology and life, something that's not well understood then or today, boom, there goes his references to God. But references to God were nowhere else in those writings. Nowhere else. He says, I suppose nobody would deny but that there's somewhat more of contrivance, somewhat more of miracle in the production and growth of plants and animals than in lifeless heaps of inanimate bodies. For the finger of God and the wisdom of divine providence is in them, much more clearly manifested than in the other. He doesn't say that about the orbits. We're done with the orbits, as Mike Shermer had noted. We're done. He's in a place where nobody really has the answer. So he invokes, this is intelligent design once again. Pure out, flat and simple. So, you know this story. I have to tell it because it's just great. All right? So Laplace, P.H.D. de Laplace, at the end of the 18th century, wrote a 5-volume tome on celestial mechanics. A brilliant piece of work. It's there. It weighs a lot on the shelf. And what it does is it takes Newton's laws of gravity and brings them into a full expression with the hammer of calculus. Okay? He brings all the armament of mathematics to bear on the laws of physics that were put forth by Isaac Newton. Isaac Newton only touched on them. They were not fully developed. And in this work, he demonstrates, he further develops something that had been percolating in the mathematical community, but he develops, and one might even say perfects, a branch of math we would call perturbation theory, where instead of pulling your hair out saying, well, how do you calculate this pair of forces and this pair and this pair, and all the equations go to hell, in perturbation theory, it allows you to systematically and reliably calculate the effect of a small tug in the presence, a series of small tugs in the presence of singular big tugs. And that's kind of what what's going on in most of the solar system. And when you do that, and you do that properly, you can demonstrate, notwithstanding the effects of chaos, which have other timescales related to them, you can demonstrate that, in fact, the solar system was stable beyond the predictions of Isaac Newton. So, he figures this out, does not invoke God, because he figured it out. And in a story that may be apocryphal, but I see more in support of it than against it, this time coincides, of course, with the era of Napoleon, Napoleon being French, and Laplace being French, no translation necessary. Napoleon, if you visited his library, it's not just sort of books of world history and battles, it's engineering books, it's physics books. This man wanted to know where his cannonballs would land, all right? He was much more than just sort of a lucky general. He was into the physics, the engineering, and the material science of war. And so he immediately summoned up the 5-volume production of Laplace, read it through, cover to cover, called in Laplace, and said, sir, I have the exact quote here. Hang on. Napoleon asked him what role God played in the construction and regulation of the heavens. This is kind of like, that's what Newton would ask, right? Laplace replies, sir, I had no need for that hypothesis. And so what concerns me now is, even if you're as brilliant as Newton, you reach a point where you start basking in the majesty of God, and then your discovery stops. It just stops. You're kind of no good anymore for advancing that frontier, waiting for somebody else to come behind you who doesn't have God on the brain, and who says, that's a really cool problem, I want to solve it. They come in and solve it. But look at the time delay. This was a 100-year time delay. And the math that's in perturbation theory is like crumbs for Newton. He could have come up with that. The guy invented calculus just on a dare, practically. When someone asked him, Ike, how come planets orbit in ellipses and not some other shape? And he couldn't answer that. He goes home for 2 months, comes back, out comes integral differential calculus, because he needed that to answer that question. And so this is the kind of mind we were dealing with Newton. He could have gone there, but he didn't. He didn't. His religiosity stopped him. And so we're left with the realization, of course, that intelligent design, while real in the history of science, while real in the presence of sort of philosophical drivers, is nonetheless a philosophy of ignorance. And so, regardless of what our political agenda is, all you have to say is, science is a philosophy of discovery, intelligent design is a philosophy of ignorance. That's all. I don't need to see have you discovered anything lately? If not, get out of the science classroom. But I'm not going to say, don't teach this, because it's real, it happened. So I don't want people to sweep it under the rug, because if you do, you're neglecting something fundamental that's going on in people's minds when they confront things they don't understand. And it happens to the greatest of the minds, as it happens to everyone else, many, if not most other people in the public. I put these up because a few days after this, President Bush, I don't remember where he said this, on the steps of the White House, in the Rose Garden or at the Capitol, in an attempt to distinguish we from they, the terrorists who flew these planes into the buildings and into the, that went down in Pennsylvania and in Washington, to distinguish we from they, he loosely quotes a phrase out of the Bible by saying, our God is the God who named the stars. Now, this is before I was on his Rolodex, okay? Because I could have helped him out there. The fact is, of all the stars that have names, 2/3 of them have Arabic names. So this was not, I don't think, his intent with that message. Okay? While the constellations are Greek and Roman, the names are Arabic, all right? And the list just goes on and on and on and on. And so where does this come from? How does this happen? How do you get stars named with Arabic names? How does this happen? And it happens because, of course, okay? It happens because there was this particularly fertile period that Professor Weinberg duly discussed. And around that period, that 300-year period, the intellectual center of the world was Baghdad. Baghdad. It was completely open to all visitors, all travelers, Jews, Christians, doubters, which today we might call atheists. They were all there, exchanging ideas. All of them. All of them. And it was that period where you had the advances in, like, engineering and biology and medicine and mathematics. All right? Our numerals are called what? Arabic numerals. They ever stop and think about that? You know, in America, do we take pause at this? Why are they called Arabic numerals? Okay, they fully exploit the discovery of the zero, create a whole field called algebra, itself an Arabic word. Algorithm is an Arabic word. All this is going on, and it's all traceable, not to some long 1,000-year tradition in Islam. It's traceable to this 300-year period. This 300-year period. And then, so they had naming rights. The most expensive, beautifully carved astrolabes come out of this period. There's a great collection of these at the Adler Planetarium in Chicago, if you ever want to check them out. So navigation, celestial navigation, all of this is traceable to this period. And so something happened. And what happened, as was previously described, I was told, and forgive me for repeating from what you might have heard, 12th century kicks in, and then you get the influence of this scholar, Al-Ghazali. All right? And so out of his work, you get the philosophy that mathematics is the work of the devil. And nothing good can come of that philosophy. That, combined with other sort of philosophical codifications of what Islam was and would become, the entire intellectual foundation of that enterprise collapsed, and it has not recovered since. Over that period, all these books were translated into Arabic on a scale not seen since then. And so why am I even going here? Because I'm trying to explain to you that you fast forward, the dangers here is that you fast forward to 21st century America and ask, what influences are we feeling now? Because that naming period in Islam stopped and it never recovered. Because the way of thinking about the natural world, revelation replaced investigation. Okay? So I fast forward to 21st century, and what do you find? You get things like this. Okay? This is in America. All right? So now, what I find interesting is the level of passion that it requires to actually do it. You gotta, like, pay for this. Okay? And it means a lot of people are pissed off at the Big Bang. They're pissed off at the Big Bang. At our museum in New York, the American Museum of Natural History, they come to the Big Bang exhibit, and sometimes I don't feel like having that conversation. I say, why don't you go to our hall of human biology first, and then come to us? And that's where we have sort of monkeys holding hands with people in skeleton forms, and then they never make it back to the Big Bang. They're gone forever. Okay? So however egregious the Big Bang is, monkeys and people is a worse transgression, apparently. So there's that, but there's also, here's a little bit of intelligent design here. Here's one that wants to accept the science, but then is like what's before the Big Bang. We don't quite know yet, so God was there. So of course, intelligent design is basically a God of the gaps. But my favorite way to end this, then, is to just reflect on, I want to do it just a fast tirade on stupid design, and this will be fast. Look at all the things that just want to kill us, okay? Most planet orbits are unstable, star formation is completely inefficient, most places in the universe will kill life instantly. Instantly. The people that say, oh, the forces of nature are just right for life. Excuse me. Just look at the volume of the universe where you can't live. You will die instantly. That's not what I call the Garden of Eden. All right. Galaxy orbits that we orbit once every couple 100 million years. You're bound to come close to a supernova that will wipe out your ozone layer and kill everybody on the surface who doesn't otherwise have dark skin, because your high energy rays will give you skin cancer. We're on a collision course with the Andromeda Galaxy. Gone is this beautiful spiral that we have. And of course, we're on a one-way expanding universe as we wind down to oblivion, as the temperature of the universe asymptotically approaches absolute zero. That's the universe. Then Earth, volcanoes, tsunami just killed, I think that number's higher, at up 200,000 people, floods, tornadoes. None of this is any sign that there's a benevolent anything out there. And this 90% should be 99%, as was earlier noted. That's of all life that has ever lived is now extinct. Inner solar system is a shooting gallery. Comets, asteroids, duck. And look how long it took to make multicellular life. Not from the beginning of the Earth. Life happened quickly, but not multicellular life. You needed your cyanobacteria to sort of crank on the oxygen, get the oxygen budget going. Then you could have that's sort of rocket fuel for multicellular creatures. But that took 3.5 billion years. That's hardly an efficient plan with us in mind. And in human beings, this is like the most tragic of them. I don't even include here the expression of free will where people want to kill each other. I'm talking about nature killing us without the help of human beings. Aggressive childhood leukemia, hemophilia, all of this. And we so much praise about the human eye, but anyone who's seen the full breadth of the electromagnetic spectrum will recognize how blind we are. Okay? And part of that blindness means we can't see, we can't detect magnetic fields, ionizing radiation, radon. We are like sitting ducks for ionizing radiation. We have to eat constantly because we're warm-blooded. Crocodile eat a chicken a month, it's fine. Okay? So we're always looking for food. These gases at the bottom, you can't smell them, taste them, you breathe them in, you're dead. Okay? So, I'm almost done. I'm sorry, I'm taking up your time here. So, and with the birth defects, most are unknown. Look at this. Others, it's like abuse and infection and stuff that human beings had something to do with. We have no idea. Oops, I pushed a button by accident, sorry. No idea. No idea. And, and birth defects are tragic. They're tragic, particularly if they happen to the family afflicted by it. And you just look at images of these aborted fetuses because of and most of these are stillborn, others are born with a heart outside the body. And so this is all simply stupid design. And the problem is, if you look for what is intelligent, and yeah, you can find some things that are just really beautiful and really, hey, that's a clever. The ball socket of the shoulder, and a lot of things you can point to, but then you stop looking at all the things that confound that revelation. And so if I came upon a frozen waterfall and it just struck me for all its beauty, I would then turn over the rock and try to find a millipede, okay, or some kind of deadly newt, and then put that in context and realize, of course, the universe is not here for us. for any singular purpose. My favorite of all is, of course, you eat, breathe, eat, and drink through the same hole in your body, guaranteeing that some percent of us will choke to death every year, okay? Imagine if you had a separate hole for breathing and eating and talking. That would be just really cool, right? Just, you could drink, breathe, and just talk, and you would never choke, all right? And it's not a hard request. Dolphins breathe and eat through different holes in their body. And that's a mammal. So I'm not, you know, this is like Santa Claus could bring this one. And this one, of course, my favorite of all, like, what's this going on between our legs, right? As you've heard, you've heard it. It's like an entertainment complex in the middle of a sewage system. No engineer would design that at all, ever. It's like the wrong juxtaposition of elements. So what I want to put on the table is the fact that I don't want the religious person in the lab telling me that God is responsible for what it is they cannot discover. Because look at the hubris of that. You're in the lab and you say, I don't know how this works. And not only that, no one alive on Earth knows how this works. And not only that, no one who will ever be born will know how this works. That's kind of audacious when you think about it. And then you put it down and go on to the next problem. If this problem is a cure for Alzheimer's or cancer or whatever else, I don't want them in the science classroom. And so the issue is simply about progress and discovery. And I bet most people in this room, even those assembled at this table, were highly concerned about the Dover trial, wondering how that would turn. And I looked at that and I said, I'm not worried, because it's a Republican judge. And in the end, if you put people who are not making discoveries in the science classroom, that is the end of the foundation of your future economy. And so I had a little more confidence than others did because of this sensitivity to the money aspect of it. But we all know tomorrow's economies will be founded on innovations in science and technology, and of course that gets cut short if we lose our civilization, as what happened in Islam in 1100. And the last thought I'll leave you with, which concerns me greatly, if you do the math, okay? You know, just look, you look at all the Nobel Prize winners there ever were, some even in this room, and ask how many were Muslim. And it's like one, maybe two. Okay, I think a second one was in economics. And the one we referred to was described earlier, the co-winner of the Nobel Prize with Professor Weinberg, Abdus Salam. And he's not Middle Eastern Muslim, he's Pakistani Muslim. Okay, now, how many Nobel Prizes are won by Jews? It's like the fourth of the Nobel Prizes. Okay, some high fraction of the total. And then you look, how many Muslims are there in the world? It's like 1 billion Muslims. How many Jews? 15 million tops. Okay? So you could ratio these numbers. Had Islam not collapsed in its intellectual standing in the year 1100, and you just do the ratios, they would have every single Nobel Prize today. So the fact that it's not only just a few, it's near zero, it is deeply worrying. I'm concerned about what brilliance may have expressed itself and did not in that community over the past 1,000 years. And so what I want to put on the table is why, so that's the end of my talk, but I want to put on the table not why 85% of the National Academy rejects God. I want to know why 15% don't. And that's really what we got to address here. Otherwise, the public is secondary to this. Thank you for your attention here.
But I'm just questioning the fact whether science should get involved in the processes of political motivations and happenings.
Can I just address that briefly? I had the honor of giving a tour of our new facility in New York. It was new 6 years ago, to Richard Holbrooke, who was shortly had finished his tour of duty as American ambassador to the United Nations. And he's a neighbor, so we did this for him. And I'm showing him the moon and the planets and the stars, and and he starts asking questions. And he says, well, how much more is the effect of the moon being closer now that I just learned that it's an elliptical orbit on the tides? I said, oh, good point. There's a strong distance dependence on tides. And we start going around, and the stars, some are red. It must be a temperature thing going on there. Yeah, some are cooler. And he starts asking these questions, and I'm saying, well, this guy just came out of the Balkans in conversations with the unrest over there, and he's asking me informed questions about the cosmos. And so I said to him, where does this come from? This is not just, where did this come from? And he said, oh, I'm sorry, I didn't tell you. Actually, in college, I majored in physics. Okay, and he switched his major like the last year or something. But he had this inculcation in sort of rational scientific thought that goes on in any physics curriculum. And I said, well, how? Then I asked your question. And I said, has this worked in any one way or another, positively or negatively, in your negotiations, in your peace talks? And he said, I cannot imagine having accomplished what I did without that kind of thinking. Because, of course, in physics, you distill a problem to its essence, find out that you shed what you don't need, look at what matters, and you discuss what matters. And when other people come in with their baggage, he cuts right through it and is able to reach consensus in ways that others can't or can't even imagine. And so getting back to Steve's point, it's not so much that a law of physics gets invoked to solve an international problem, but certainly the training that goes on in the mind of a scientist has got to be useful in solving problems, even interpersonal problems, more useful than not having that kind of background, as evidenced by at least this one
I agree with what you said.
I can have one last comment on Richard Dawkins. It'll be quick. I was in the back row as you spoke, and so I could see sort of the whole room as the words came out of your mouth, as beautifully as they always do, and as articulately as they always do. And let me just say, your commentary had a sharpness of teeth that I had not even projected for you. It's more. This is my first time meeting him, and so I felt you more than I heard you, and I asked the question, and it gets back a little to what Francisco was getting at. You're a professor of the public understanding of science, not professor of delivering truth to the public. And these are two different exercises. One of them is you put the truth out there, and like you said, they either buy your book or they don't. Well, that's not being an educator. That's just putting it out there. Being an educator is not only getting the truth right, but there's got to be an act of persuasion in there as well. Persuasion isn't always, here's the facts, you're either an idiot or you're not. It's here are the facts, and here is a sensitivity to your state of mind, and it's the facts plus the sensitivity, when convolved together, creates impact. And I worry that your methods and how articulately barbed you can be ends up simply being ineffective when you have much more power of influence than what is currently reflected in your output.
I gratefully accept the rebuke. Just one anecdote to show that I'm not the worst in this thing. A former and highly successful editor of New Scientist magazine, who actually built up New Scientist to great new heights, was asked, what is your philosophy at New Scientist? And he said, our philosophy at New Scientist is this: science is interesting, and if you don't agree, you can fuck off.
But what I want to know is, we're in one of the greatest centers of neurophysiology. I want somebody to put electrodes on my head. And when I reflect on our kinship with the cosmos, when I do the calculation that shows that a 15-ton meteorite that we have in the center of the Rose Center for Earth and Space, it's an iron meteorite. When I do the calculation that shows that if you take all of the iron from the hemoglobin of the people in the tri-state area of New York City, you can recover that much iron out of their blood, and realize that the iron from that meteorite and the iron from your blood has common origin in the core of a star. Tell me what part of my brain is lighting up, because that excites me. That makes me want to grab people in the street and say, have you heard this? when it was announced that we were going to cancel the Hubble telescope, the greatest outcry to not do that was not the astrophysicists. It wasn't from within NASA. It was the public. It was all over the op-ed pages and the talk shows. The public took ownership of the Hubble Space Telescope because the universe was coming into their bedroom, into their living room, onto their computer. They were a participant on the frontier of discovery. And as far as I can tell, if you let them know that it's not simply that we're in the universe, but in fact, given the chemistry of it all and the nuclear physics of it all, not only are we in the universe is in us. And I don't know any deeper spiritual feeling than what that brings upon me. And I just wanted to leave you with those thoughts. Thank you.
Is it the fact that people are just simply curious about things they don't know about and curious about the future?
We were once, every one of us to a person was deeply curious about our environment as children. Scientists tend to not ever lose that, and they stay curious their whole lives. I think other people get it beaten out of them, they get it worn out of them, and so I'm in search of that soul of curiosity that I think continues to lurk in all adults.
So what happened? Do we tamp it down? Do we, in a sense?
Yeah, what happens if you're in a class and you say, oh, what's that? Let me go to the window. No, sit down. It's not time. You know, do your lesson.
And just listen to me talk rather than engage.
Exactly. And our school system tends to be reward people who obey, people who do exactly what they're told, people who hand things in on time. Those are the honors, the best students as we have come to define them. Yet the student who's distracted by the butterfly could be the next great naturalist, but that doesn't get rewarded in school because you should be studying for this curriculum that we've established for you. So I think we should do it all, but don't suppress. Yes, you need a curriculum. Yes, you need exams. But if you see energy in a student being expressed by questioning their environment, that should be nurtured, not somehow declared that it's out of line. I think some people still look up.
Yeah.
And you can't help but wonder, with all these stars, we know enough to know that they're stars just like the sun, and they've seen the newspaper headlines, they're planets orbiting these stars, and if they're planets, how could you not wonder if there's life? And if there's life, is it intelligent life? And if it's intelligent life, could they be smarter than us? If they're smarter than us, should we be scared of them? Or should we, there's a whole...
So what's your best guess?
My best guess is that the universe is teeming with life.
The universe?
Well, and our galaxy in particular. Our galaxy is sort of proxy for other galaxies, is teeming with life, but that complex life might be much rarer.
Why is that?
Well, here's the argument. You have the timeline of the Earth. Earth is born, and this is today. That's 4.5 billion years.
Yeah.
Now, put this planet out there, and some planets are born yesterday, some were born at the beginning of the universe. You don't know when in the timeline of a planet you're going to land there. So here's Earth. Throw a dart at the timeline. Most of the time the dart hits Earth, there's only single-celled life.
Wow.
And so if we are randomly coming upon planets and Earth is any measure of things...
Single-cell life is like an amoeba? Is that what
Yeah. We spent 3.5 billion years as single-cell life on Earth. And then we have something called the Cambrian explosion of life, where the chemistry of the atmosphere changed. There's oxygen. Oxygen is like rocket fuel for complex life. And life now has the carte blanche to become complex because the system can support it. And now you get limbs and detectors like eyes and sensors and it's a stunning development in the fossil record of life on Earth. And so then you'll have complex life. Now I ask, so that's a smaller piece of the total timeline. Now you ask, how often when you throw the dart will you find intelligent life? Well, that's this little bit that we define as intelligent. And so if Earth is any measure of anything, throwing darts at planets that we might land on, who is to say that we're going to land right at that moment where what we call intelligence has arisen? Maybe that planet has conditions that are especially ripe for complex life, and they started complex life early. If they did, then they would have billions of years to develop intelligent life. And if that's the case, it is quite clear to me that if they observed us, landed here and looked around, it would be clear to them that there is no sign of intelligent life on Earth. Yeah.
What's on Mars?
The rover is on Mars. I'm happy to report a working.
Pretty good.
The Curiosity rover is the size of an SUV.
Is it still projecting?
Yeah, it's still.
So what's up there?
Well, Mars is
water.
Is curious. The Martian surface has rampant evidence of there once having been running water.
So that says something.
Yes. And so what I mean by evidence, I mean really awesome evidence. Like there are river beds that dried meandering riverbeds.
Wow.
The things, if you fly over the Midwest and you look at the things that floodwaters have done and longtime rivers have done, cut into the landscape, the Grand Canyon kind of things, you see all of these telltale features on Mars.
So when did we see them? When do we know that
anytime we take a photograph of its surface. It's
so we could have known that without going there?
No, the resolution is very hard to pick up. That's hard. You want to get close, and then you can see ridges and valleys and mountains.
So that tells you water was there.
Yes, or a liquid. We're pretty sure it was water, but it's certainly a liquid. And by the way, to meander a river means the river was there for some time. All right, that's you don't meander overnight. This is a very slow thing that rivers do. Not only that, there are dried lake beds where you see salt deposits at the bottom, and how do you get salt deposits? You get that from standing water that had minerals deposited in it. The water evaporates, concentrating the mineral deposits, and when there's no water left, you get a salt lake. You fly over Utah, that's what what Salt Lake City is sitting next to.
Should we go to Mars?
I want to. Yeah, why not? What?
It's feasible and doable.
The only challenge. People say, "Oh, the radiation." We have clever engineers. I have no doubt that they'll figure out all the technological problems. It's money. It's just money.
Is it really?
Oh yeah. It's only ever money.
Yeah.
Only ever money at all times.
Are you supremely disappointed that we don't do more in space?
The curiosity part of me is disappointed, but the politically astute side of me fully understands why that's the case. We went to the moon because
we have other priorities.
No. We always had other.
It was a PR move.
We've always had other priorities. So that's a false excuse. When we went to the moon, we had plenty of other priorities. There was a civil rights movement. There was the hot war in Southeast Asia, the Cold War with Soviet Union, campus unrest.
So we did it for PR.
We did it because we were at war with the that was an act of war essentially without the weapons. And if we were not at war, the motivation to go to the moon, we tell ourselves, "Oh, we went to the moon because we're Americans and we're explorers and it's in our DNA." Okay, that might all be true, but the people who write the checks don't give a rat's about any of this lofty speak. Is your security at risk? We will spend any amount of money to protect that. And that's when money flows like rivers, and we went to the moon.
President Kennedy made a commitment
in that climate.
But should we create that kind of urgency again for something like going to the moon?
You know what I joke about?
No.
I joke. I say, let me go visit China and whisper to the head of China, "Psst, can you leak a memo that says you want to put military bases on Mars?" Just go ahead. Shh, don't tell anybody. Then that memo shows up in the Pentagon. We will be on Mars in 10 months, I'm sure. 1 month to design, build, and fund a spacecraft, and 9 months to get there. We'll have astronauts. That's how motivated I think we would be, because that's how motivated we were back in the 1960s. Now, I don't want to go to Mars for military reasons. I think there's a strong economic reason one can make for it. It's a little more subtle, and I think it takes slightly longer than the proverbial elevator ride that you have to save up for your member of Congress. Right. This takes maybe twice as long as an elevator ride. And I'm thinking, I voted for my representation in Congress. I want them to listen to me for longer than an elevator ride. So it's simple. If you're going into space in a big way, visiting asteroids, mining asteroids, tourist jaunts to the moon, science on Mars, you're doing all of these activities. There might be military activities, all of this. To accomplish this will require advancing a space frontier. You'll be inventing, innovating, patents will be granted, and you'll have these discoveries writ large weekly, if not daily, in your newspapers. And that that infuses a culture of inquiry, a culture of exploration, a culture of innovation. And when you come from a culture of innovation, stuff gets solved when you encounter a problem, because your whole mindset is different.
Do you believe we have lost the culture of innovation?
Yes. It's been gone since we stopped going to the moon. It's been gone since the 80s.
Look what we've done in Silicon Valley. That's a culture of innovation.
Yes, it is. Yes, it's a great culture of innovation. But I was misrepresented in some headlines when I said I gave a talk, and at the end of the talk, in response to a question, someone says, "What do I think of that?" I say, "Well, the world has problems that are bigger than can be solved just waiting for your next app. We have problems in transportation, housing, poverty, disease, energy, climate. And so these are huge problems. And if we all sit down and play with our apps, they're not going to get solved." That's what I said. The headline was Tyson attacks entrepreneurs, saying that they're like cavemen.
But so what did you mean?
No.
What did you mean?
What I mean is to bask in the pleasures of your next app will hide from you the fact that there are larger problems that need to be solved. So, yeah, he said it better than any of us, connecting science literacy with what it is to have an informed democracy. If you want to take control of your fate, you can't do it if you are misinformed or underinformed about what actually matters. And in the 21st century, it's going to matter. Yeah, I think a lot of focus tends to be on who are the brightest students, can we get them interested in science, and then can they invent something to save the world? I think there will always be the smartest kids in a class.
Right.
There will always be that. And so I'm not really worried about them. I'm worried about the rest of everyone else who is given the freedom to say to themselves and to others, "Oh, I was never good at math, ha, ha, ha." Or science, that's not for me, I'm into this other stuff. And somehow be okay with that. Suppose I said to any other person, I don't read because I was never good at nouns and verbs. I stick with science. You would laugh me out of the room. These are fundamental parts of civilization. The arts and the sciences have defined civilization ever since there's been civilization. To separate yourself from one or the other and claim to be informed, as the good Dr. Sagan said, that is a combustible mixture, especially if that kind of ignorance is wielded by people in power. So for me, it's sufficient to say, let us spread an appreciation of science to everyone. They don't have to be scientists, but understand what it is.
If they understand it, they're more likely to support it.
Sure, but it's not support it like it's a thing. And
it is. I mean, it's clear what you're supporting. You're supporting the idea that science is important, and you're creating a culture that respects it and therefore wants to enhance it.
Couldn't have said it better myself. So if the people understand what science is and how it works and why it works, then you can vote intelligently on issues that involve scientific principles.
And things like climate change.
And issues. And then you can know who is not telling the truth and who is.
Okay,
you can
but my
analyze
question is, do we have too many scientific deniers in our country, or do we give too much prominence to those who want to look the other way at science?
There's some of those. And dare I implicate some elements of journalism in this, because there's your journalistic ethos, not to tell you what your ethos is, but as I understand it, and it's been told to me, the journalist obligation when writing a story is to give equal column space to all sides, or half to one of each side. And if someone says the earth is round and someone says the earth is flat, at some point you're going to make a judgment. The earth is flat, people, is just flat out wrong. Right. I will not be giving them the attention. We're wasting time, and I'm not doing a service in my role of informing the public. And so I think journalists are really smart people, and they're highly educated, and they're curious. They have the curiosity that kids have that they still have as adults. That's the other kind of branch of curiosity manifested in society, scientists and journalists. And that's a great thing to have. But at some point, invest your brain energy to recognize when something is fringe and report it that way. And so when you do that, people then are properly informed about what is and is not true, what is an emergent truth, what is a truth that's in doubt, what is a truth, what is something that has been refuted. Be responsible on that frontier, and I think that'll help.
Explain to me time travel.
Well, it's been suggested that there might be some law of physics we have yet to discover that will prevent you from going backwards in time. Because think about it.
It's been said that
maybe there's a law of physics we have yet to discover that will declare without hesitation that thou shalt not go backwards in time. Because if you do, and you prevent your parents from meeting one another, unlike the Terminator series where you have to kill people so that they don't mate, all you have to do is prevent them from meeting or prevent them from having sex. That's really all you have to do.
And you're right there.
And then whoever started the revolution is not there. Have the people have sex 10 minutes later than they otherwise would have. You give birth to a different person than who would have led the revolution. Yes. But then it wouldn't have been the gore fest that it turned out to be. If you go back and prevent your parents from meeting one another, you would have never been born to have then lived to go back in time to prevent your parents from meeting one another. So you have this paradox. It's a causality paradox. And so, but that being said, we have no shortage of interesting ways to go forward in time. And we can speed you up, send you on a spaceship, you go very fast. Your time ticks more slowly, not just your clock, and then the electronics in your digital watch I see you have, but your physiology, everything about you will tick more slowly. You will age more slowly than your twin here on Earth. You come back, you will be younger than your twin. So you have effectively gone into the future. That's one way to do it. You can also do it by, in gravitational fields, you can, as they portrayed this in the film Interstellar. Yes. Very strong gravitational fields also have an effect on at what rate your time ticks. And we can measure this, by the way. The GPS satellites that are farther away from Earth's center than we are, their time ticks at a different rate than ours does. Their time ticks more, the clocks on GPS satellites tick faster than clocks on Earth, but they send you the correct time. So how do they do that? Yeah. We knew in advance about Einstein's general relativity. So the GPS satellites are pre-corrected for this time change by the formulation of Einstein's general theory of relativity. And now it can send the correct time down to us. Otherwise, the times would separate from one another, and you couldn't use GPS satellites to tell you anything about where you are on Earth's surface. So this is real. It's physics. It works. I think the single greatest gift that astrophysics has brought civilization is the discovery back in 1957 by 4 authors. No movies are made about them because it's 4 of them, not just one. And we romanticize the lone researcher burning the midnight oil. This is 4 scientists working for a decade to get this result. They realized that the elements on the periodic table that we might remember from chemistry class owe their origin to thermonuclear fusion in the cores of stars. Fusion, light elements under high temperatures coming together to make heavy elements. If they only stayed in stars, that would not be interesting. But these particular stars also happen to explode and scatter this enrichment across the galaxy. And this enrichment, carbon, nitrogen, oxygen, silicon, all of these elements scatter into gas clouds that then collapse and form next generation star systems, one of which was ours. Yeah. So the very ingredients that comprise life are traceable to stars. So they gave their lives billions of years before we arrived. So we are stars? So we are not only figuratively, but quite literally stardust.
Wow. But do you have things you want to accomplish?
I would say one of my favorite quotes, I don't remember if I told this to you in the 60 Minutes piece, one of my favorite quotes was uttered by Horace Mann, the educator, who said, "Be ashamed to die until you have scored some victory for humanity." And I want that on my epitaph. I want to be buried, and I want that on my tombstone. And
be ashamed to die unless you've scored a victory for humanity.
Scored some victory for humanity. And by the way, that could be at any level. It could be raising kids that, you know, are responsible. You know, that's a very broadly defined victory. And so I think I'm not the first to say this. At least leave the world a little better off for you having lived in it. Just why not? Just it's like clean up your mess. and after you've cleaned up the room that you just lived in, maybe leave a flower behind. Something where people can come in and say, this is a slightly better place. And then we could all celebrate each of our existence in this world and not lament it or regret it. Or there's so much in the world that regresses civilization. I mean, it's sad. I wonder how far we would be were it not for such forces that operate in this world.